Chapter 8, Section 2 was about multiplying and factoring. All right, so you should be able to simplify polynomials using multiplication, including the distributive property, which is also known as FOIL. Okay, so we're just jumping right in, actually, and learning how to simplify using the distributive property. So, just like the distributive property was before, we're going to share what's on the outside with everything that's on the inside. So we're going to take this negative x to the third and we're going to multiply it with all three of these things on the inside. Okay, now remember back to chapter 7, whenever we multiply two numbers with the same base, two powers with the same base, we actually add those exponents. So this would be like a -1. So what we're going to do first, when we do -1x to the third times 9x to the fourth, is that we're going to multiply the coefficients. So -1 times 9 gives me that -9. We have an x as our base, and we add the 3 and 4. So we really have -9x to the 7th power. Next, we have -1x to the third times a -2x to the third. Negative times negative gives us a positive 2x, and 3 plus 3 is 6. Okay, and then the last one is -1x to the third times 7, which is a -7x to the third. And that is what they're looking for. All right, so in this second example, 5n times 3n to the third. 5 times 3 is 15. N to the first times n to the third gives me n to the fourth. 5n times a -1n to the second gives me -5n to the third. And then 5n times 8 gives me a positive 40n. Awesome. Okay, last one before we start working backwards. What is the simplified form of x to the second power times 3x to the third minus 2x to the second plus 8? This is a great place for you to pause, try it on your own, come back and see if we get the same answer. Okay, welcome back. When I distribute x to the second times 3x to the third, I get 3x to the fifth power. X to the second times a -2x to the second is -2x to the fourth. And then x to the second times 8 is a positive 8x to the second. Hopefully you got that same answer if you paused and tried it on your own. Okay, now we're going to start working backwards, and this is called factoring. We're going to be undoing the distributive property. We just distributed, and now we're trying to figure out what we can actually take out to undistribute. Okay, the first step is to find that greatest common factor. We're looking for the number that every term would have been multiplied by, or what was distributed to each term, and that's called the greatest common factor, that number on the outside. Okay, so now I know we found this greatest common factor way back in 5th grade when numbers were much more simple. This time, we have variables too, so it's a little more complicated. All right, so the best way to describe that is that we're going to list the prime factors of each term. Okay, so 5x to the third. The only thing that I can do to multiply to get to a 5 is a 1 and a 5, and we never have to list the ones. So they have 5, and then x to the third gives me the 3x's. Okay, 25x to the second power. We have a 5 and a 5 because 5 times 5 is 25. And then x to the second power gives me these 2 x's. 45x gives me, I have to break it all down. And it actually ends up being 3 times 5. And because there's only one x in the term, there's only one x here. Now we have to look for what they all have in common. They all have a 5. They do not all have a 3. But they all have an x. There's nothing else that they have in common. So then our greatest common factor we list as 5x. Okay, that's what we would take out of this function up here, this polynomial, and then I'll show you the rest after that. Okay, so we're just looking for greatest common factors. So in this one, we're going to break down what 3x to the fourth looks like. So if I have 3x to the fourth, I know the only things I can multiply to get a 3 are a 1 and a 3. So I'm going to list the 3, and then I'm going to list all 4 of the x's. Okay, for negative 9x to the second power, 3 times 3 would give us 9, and then I still have 2 x's to list out. And negative 12x, remember I can only use prime factors when I'm looking for the greatest common factor, so I have to break it all the way down to 2 times 2 times 3, and then I still have that 1x I have to account for. Now if I'm looking for things that all 3 terms have in common, they all have a 3, and they all have at least one x. Nothing else can be found in all 3 lists, so we're going to say that our greatest common factor is a 3x. Okay, what is the greatest common factor here? I think it would be best if you paused and tried to figure it out yourself, and then come on back and see if you agree with what I have. Okay, if you're coming back now, I'm just listing common factor, or all of the prime factors, so that I can find my greatest common factor. Okay, they definitely have these 2's in common. They all have a 3, and they all have an x. Okay, so that means I have 2 times 3 times x, which gives me a greatest common factor of 6x. Okay, once you find that greatest common factor, you can factor it out of the polynomial. That means actually pull it out, and on the inside of your parentheses will be what you have left once you've taken it out. So the first thing we need to do is actually find the greatest common factor. So if I'm looking for the greatest common factor, I'm going to list what I can. So I have 2 times 2 times 1, 2, 3, 4, 5. And then I have a 24x to the third, which gives me, 2 times 2 times 2 times 3, and then 3 x's. And then our 8x is 2 times 2 times 2 with 1x. Okay, so greatest common factor. Let's see, they all have 2's. They actually all have another set of 2. And then they all have 1x. So we have 2 times 2 times x, which equals 4x is our greatest common factor. Now, what we mean by factoring it out, I'm going to put 4x on the outside. Means I'm pulling 4x out of each one of these. Okay, so when I distributed, I multiplied. When I'm working backwards, I'm undistributing, I'm dividing. So if I'm pulling 4 out of this first term, 4 divided by 4 just leaves me with 1. And if I pulled one of these x's out, that means I only have 4 left. So I have x to the fourth. Then we have the minus, so we're going to put that in here. 24 divided by 4 is 6. And if I pulled 1x out of here, that means I have 2 left. And last, but no, then I have plus. And then last, I have 8x, and I'm dividing that by 4, which leaves me with the 2. And if I took 1x out of there, I took 1x out of here, that means I don't have any x's left. This is the factored form of this polynomial. That's what they're looking for. Okay, the rest of this is mostly just practice problems. However, I am going to show you that if you don't want to list out every prime factor of each of these, you can just look at what does each term have in common. Okay, so first thing you want to look at is what can each of these coefficients be divided by. In this case, I'm going to say they can each be divided by 3. Okay, then how many of these variables does each term have in common? Or what is your smallest exponent? Okay, this one has 2 x's. that means, and this one definitely has 2, this one definitely has 2. There'll just be some left over. So you always want to use your smallest exponent. So 3x to the second power is actually our greatest common factor. Now, when I know that, I can pull that to the outside and figure out what I would have left on the inside. So 9 divided by 3 leaves me with 3. And I pulled out 2, so that means I have to subtract 2. So I have 3x to the 4th left there. Plus 15 divided by 3 gives me a 5. And since I pulled 2 out, 4 minus 2 leaves me with 2 x's. Then I have a plus again. 12 divided by 3 gives me 4. And I pulled 2 x's out, and that doesn't leave me with any more x's to be had. This is our final factored form. Okay, this one, the number that they can each be divided by is 6. And the smallest exponent is 2. So 6x to the second power is our greatest common factor. When I pull 6x to the second power out, that means I'm dividing each thing. Okay, so this one, if I do negative 6 divided by 6, I get a negative 1x, and I took 2 x's out, so I have to subtract 2. So I have x, to the second power. Negative 1x to the second power. Then I have this minus. So 18 divided by 6 is 3, and since I pulled 2 x's out already, I only have 1 left. Minus again. 12 divided by 6 is 2, and I pulled 2 x's out, so that actually means I don't have any x's left for that. Now, if you, in your head, it made more sense for you to pull out a negative 6x squared, we could also write it like this. That would turn everything on the inside into positive, so we would have x squared plus 3x plus 2 with a negative 6x squared on the outside. Both of these would be okay. All right, I'm going to have you try this one on your own and then come back and just see my answer. I'm not going to show all the work this time. I just want you to come check to see if your answer is the same as mine. All right, welcome back. I pulled 11w to the third power outside, and that left me with 3w to the fourth plus 5w to the second minus 2. All right, this one gets a little weird because now we have two variables, both with different exponents. Okay, but I know that 13 and 39, I can pull a 13 out of both of those. Then my c's, the lowest exponent is this 1 right here, so I can only pull 1c. And my smallest exponent for the d's is a 2. So 13 cd to the second power is my greatest common factor. That's what I'm going to pull out. 13 cd to the second power. Okay, on the inside, that leaves me with 13 divided by 13 is 1. C, I took this 1c out already. So all I have left is 1d. Then I have a plus. 39 divided by 13 is 3. I only pulled 1c out, so I have 1c left. And I pulled 2 d's out, so I don't have any d's. That's my final answer. Okay, now that you've done that, try this one on your own. Come back and see if your answer is the same as mine. Okay, I'm factoring out 5, 1x, 2 y's, and that leaves me with x to the second times y to the second minus 5. All right, everybody's favorite, word problems. This time, this is a helicopter landing pad or helipad. It's sometimes marked with a circle inside a square so that it's visible from the air. What is the area of the shaded region of the helipad at the right? Write your answer in factored form. Okay, so to find area of a square, we're only looking for these red pieces, the area of that. But that makes up a square at first if there was no circle. So the area of a square is length times width. Okay, in this case, because it's a square, we have 2x times 2x, which gives us 4x squared. Then we have to get rid of this. Okay, well, the area of a circle happens to be pi times the radius squared. Okay, and our radius in this case is an x, so I'm going to take this out and put in an x. Okay, now I have to subtract these. So 4x to the second power minus pi times x to the second power. Okay, well, I know that these both have an x to the second power in common, so I'm going to take that out, and that's going to leave me with 4 minus pi on the inside. Okay, kind of weird with the pi, but we actually leave it with the pi so that we get the most accurate answer. Okay, now here's your chance to try the same thing. A circle with radius r is cut from a square that has side lengths 3r. Write an expression in factored form for the shaded area. Why don't you try this one and then come back and see if your work matches mine. Okay, now I'm going to factor out the r squared, and that's going to leave me with 9 minus pi. And that's it for today. Your assignment is on page 483, numbers 9 through 39, and then your lesson quiz.